Okay, now we're on section 2.3, and the thing we start off with is this multiplicative identity. Multiplicative, okay, identity. And, so we had the additive identity, or so remember we had the zero matrix plus some matrix A just gave you A, right? Well, in scalar multiples, we had a 1 times A also gave us A. But what about a matrix, right? And I've alluded to this a little bit, but there is this matrix, we call it I, and if I take I times A, I get A. What's also very important is if I take A times I get A. Now the funky thing here is that these may not be the same matrix. Okay, they may be, but they may not be. And in that, what we mean is that, remember, if A is m by n, okay, A is m by n, then if I multiply on the left by something, I times A, well, then the I here has to be something by m, okay, in order to make that multiplication work. On the other hand, if I take A times I, then I has to be n by something. And otherwise the multiplication won't work. Well, if m and n are not the same, then those two matrices would not be the same. So it's kind of a strange sort of thing. The identity may change depending on which side you're on. But I is just, and I'm going to use an n, I could use an m, it doesn't matter, but I is an n by n diagonal matrix. Now, by diagonal, what we mean is when you look at a matrix, the diagonal, you might say there are a couple diagonals. Yeah, but the diagonal we talk about when we talk about the diagonal is from the upper left up here down to the lower right. So it's an n by n diagonal matrix, and by diagonal we mean, okay, so it's got that, but then everything else, all that stuff's zero. With all ones in the diagonal. Okay, so 1 0 0 1, that's an identity matrix. 1 0 0 0 1 0 0 0 1, that is an identity matrix. And yeah, I'll do one more, what the hey. 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1 is an identity matrix. So all of those are identity matrix. They're diagonal in that the only non-zero elements are down that diagonal from upper left to lower right, and everything else, so everything else is zeros, and then those non-zero elements that happen to be in the diagonal, they are all ones. So that is an identity matrix, and certainly what we see is if I take something like that and I multiply by, well, we'll just do a vector here, xy. Well, I get x, because 1 times x is x and 0 times y is 0. Add those together, I get x. And then 0 times x plus 1 times y, I get y. See, so I have this here. And now if I just made this a bigger matrix, right? Well, each time I multiply, I'm just doing the same thing to each column. So, you know, there's XY, WV, you know, RS, right? It'll do that same thing to each column. And so I'll get XY, WV, RS. I just get the same thing back. And in this case, you know, well, no, neither of these cases. These are rectangular matrices. They're not square. But if I have a square matrix, then, you know, this 2 by 2 matrix, then this particular diagonal would work on either side. But like this matrix, I would need a 3 by 3 diagonal. So let's try that. You know, so if I have X, W, R, Y, V, S times the 1, 0, 0, 0, 1, 0, 0, 0, 1, then you see when I take XWR dotted with 1, 0, 0, I just get X. XWR dotted with 0, 1, 0, I just get W. And XWR dotted with 0, 0, 1, I just get R. And then the same thing on the bottom, I end up getting YVS. So you see, I just got that same matrix back. So that is an identity matrix.